Welcome to the Tuesday discussion with Sebastian Seibold. My name is Christoph Mauch. I'm the director of the Berchtesgaden Center, and together with Gesa Lüdecke, I'm running the Tuesday discussions. Actually, today it was Gesa's turn. We are alternating, but Gesa sends her regards. Maybe she's online. If she's online, greetings and good recovery. She's actually, unfortunately, in bed with the flu. Also, we had originally hoped that Sebastian could be here, but he was in Munich yesterday. He has to be in Berchtesgaden tomorrow. And if you know the trip by car, it takes 2 times 3 hours back and forth. And just to come for 1 hour, it didn't really make sense. But we are super happy that Sebastian, nevertheless, has joined us online. And we're excited to have him here. Well, virtually behind me on the wall. Sebastian Seibold is actually both a professor at the Technical University in Forestry, Forest Management, and somebody who works in the national park. You know that Bavaria has 2 national parks. We will actually visit one of them. All of you are invited to join us in July. And the one that is the Alpine Park, this is where Sebastian works in Berchtesgaden. It's a city next to it. The other one is the national park, the national forest, Bavarian National Forest, at the eastern border of Bavaria. And Sebastian knows both of them. He knows forestry really well. He did his first PhD in the Bavarian Forest National Park, which some of you know was really hit badly by the first storms, then the bark beetle. And so there was a lot of deadwood, and he did his PhD about deadwood and its connection to biodiversity. Very interesting what happens, you know, when you have a lot of dead wood. Does that increase or decrease biodiversity? You can ask him, or he may address that. But he's now in the other park, which is right at the Austrian border. And you can imagine it's a park that has very steep heights also. Berchtesgaden is probably 600 meters altitude. And the upper areas of the national park are probably about 8,500 feet, 2,700 meters. So it's a real alpine park. And that's where he does his research on flora, fauna, biodiversity, climate, all sorts of things. Forests, of course, he's a forester, and he's obsessed with, I can say that. I think he's been obsessed with trees, at least it seems to me, because those of you who are Germans know or may know that we used to, instead of doing military service, we had the option to be conscientious objectors. And for instance, I did work in an old people's home and in a prison. But Sebastian was already interested in trees early on, and there was a chance, which I didn't even know, to do an environmental civil service instead of military service, and he went for that. And so he was, for a long, long time, more than probably anybody I've ever met, he was just counting trees, tree seedlings, very little trees in north of Munich. So he knows a lot about trees. He went from the national park in Berchtesgaden, from the Bavarian one at the border up there, to America. He went to work for the National Park Service in Athens, Georgia. It's the southern part of the United States, National Park South. Not Washington, D.C. And then he also went for a whole year to the national parks in Toronto. So you see where he's coming from. I could tell you more about his research, but I think I've already told you enough. You know who he is. He's a professor. He's has a lot of experience in national parks, in ecosystem management and in forest management. And I can't wait to hear from Sebastian, Mr. National Park. Thanks for joining us.
Thank you very much for the invitation, also for this kind introduction. Well, I hope I won't disappoint you. With my talk, I tried to do not a classic like research talk, talking about one project or an outcome of a project or something like that, but I tried to bring some different studies together and some different questions. And I think altogether, maybe they could be a nice basis for a vital discussion afterwards. So what I want to talk about today is about the state of biodiversity globally and more locally, and particularly about the role of land use and climate change. And now it works. So I think this is not a surprise to any of you that biodiversity globally is not doing that well. So if you look at the rate of extinctions across different groups, of course, prominently mammals, birds, and other vertebrates, but also many invertebrates, then we see that extinction rates today are way above what we would naturally expect, like the natural background extinction rates. So this is, of course, driven by what we are doing as humans, how we change our landscapes and how we alter ecosystems and so on. So we are strongly changing biodiversity in terms of which species are occurring. And this is also visible if you look at communities and how they change over time. So the similarity of biological communities over time is basically decreasing. So we see that communities are changing, communities are becoming more homogeneous across landscapes, and this is of course linked to declines in biodiversity. So I think quite prominently the IPBES, the Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services, they summarized in their report quite recently that if we compile all the knowledge about population status of species globally, then we see that about 1 million plant and animal species globally are threatened with extinction. So if we continue as we do currently, then we might see many of these species going extinct over the next decades. So this is all quite alarming, but still it's on a large scale. Like if we talk about biodiversity globally, then, well, many of us might think, well, this is maybe like in the tropical rainforest, the Amazon is being degraded and so on. But this is something that is happening basically everywhere. So it's happening here in Germany, but it's also happening in North America and across more or less all continents, at least as far as we know. So biodiversity decline is really happening in our backyards. And I just picked two examples. One is a very prominent one, and you might know about it. This is the results from the study by Kaspar Hallmann and colleagues published in 2017 in PLOS ONE. And they used data, insect biomass data collected by citizen science, more or less citizen science volunteer entomologists from the Entomological Society of Krefeld. And in this paper, they showed that insect biomass declined by around 80% over the 30 years they looked at. So this was quite alarming, and I think it was one of the first studies that really brought the decline of insects, not only the decline of in some vertebrate species like the panda. Everyone knows the panda, of course, but so far not many people cared about insects. And I think this was one of the first studies which really pushed insects and the decline of insect populations and made it a political issue and brought it up on the political agenda. But of course, this was not the first study showing something like that. For example, here, already published in Science quite prominently, Thomas and colleagues showed that butterflies in the UK declined on average quite a lot. So we have been aware of this already for quite long. At least many scientists did, and also many field entomologists, but it took quite a while to become or to raise public awareness. And I think now the big question is, what are the drivers behind these declines? Of course, habitat loss, so degradation of natural habitats and so on. The homogenization of landscapes is probably one of the big drivers. We often discuss about agricultural land use and land use practices like nitrogen deposition, pesticides, of course, and so on. But of course, also climate change directly affecting metabolism and thermal tolerances of species, but also changing ecosystems by, for example, die-off of trees and so on, could also be a driver of biodiversity change, let's say. And then there may be further smaller drivers like light pollution when it comes to insects, or maybe other things we haven't really thought about yet that much. So I think the big question is, how are these drivers interacting, and what is the individual role of these drivers? And I've been involved in a project a few years ago, the Biodiversity Exploratories, which is quite a broad project funded by the German Science Foundation, being conducted in 3 regions across Germany. You can see them here on the map. And in this project, many researchers from different universities across Europe try to do research on how land use is affecting biodiversity and ecosystem functioning and so on. And I was involved in the arthropod monitoring, and at this stage we already had collected data on arthropods for 10 years. So like my colleagues already started that much earlier. And when this strong debate about insect decline started, we said, well, we only have 10 years of data, which is pretty short as a time series, but still let's take a look if insect populations changed in our data already. And we did that, and it was quite surprising how strong the results were, which we found. So what we found was, for example, that the overall diversity across all sites in the forests and grasslands which we investigated declined in species richness over the 10 years of the study. So you can see that every year, of course, there's some ups and downs, but every year there's a bit less of species richness across these sites. And I think, yeah, this result and some further results I will show you in a second were quite strong and shocking, and therefore it was quite nice that these findings were picked up by the media and once more stimulated the public debate about the fate of insect biodiversity and land use in particular. And one thing that was really interesting about our study or our findings was that we were able to link the magnitude, the strength of the decline in insects on our sites to agricultural landscape in the surrounding areas. So we had only a very coarse measure, which was the cover of arable fields in the surrounding, like 1 kilometer radius area. And we found that the declines were way stronger at sites surrounded by more agricultural or arable fields than at sites with a low proportion of arable fields in the surrounding. And even if this does not specify whether it's pesticides or habitat loss or something else, it's a strong indicator that the declines have something to do with agricultural land use. We also looked at forests, and here it was a bit more complicated. We found no connection to agricultural land use in the surroundings, but we found quite an interesting pattern that the declines were weaker at sites which experienced some tree mortality compared to sites which remained stable and where no trees died and the forest canopy remained closed. So at sites which had some tree mortality, irrespective of whether it was natural mortality or maybe anthropogenic mortality due to forestry, insects declined less. And this is something we have to do more research on, but it seems that this increase in light availability and deadwood and all these things promote insect biodiversity and could be something that helps against this overall decline in insects. But the data we have in form of time series, so really measured data at one site over many years, we don't have much of this kind of data, and at least not standardized data. So this is really hard to identify drivers from such kind of time series data. So what is very interesting at the moment is that we get more and more studies which use space for time approaches instead of time series. So instead of measuring something at the same point over several years, in these studies, sites are selected which differ, for example, in land use, and then sampled at the same time. And then by comparing the pattern between these sites, we can draw inferences about potential drivers also along temporal gradients. So I want to show you briefly one study which was conducted across Bavaria, and in which many sites were selected to create gradients in land use from agricultural areas to forests and to urban areas. And here insects were sampled, both biomass and species numbers. And what we found was quite interesting, that the lowest level of biodiversity of species numbers was found at arable fields. So this was not so surprising. So this is like agricultural areas with not much habitat and so on. Here we have the lowest numbers of species. But in terms of biomass, arable landscapes are actually quite good. They have quite much insect biomass. Where we found lowest insect biomass was in urban areas. So probably in urban areas where we have a lot of sealed ground and not much green space, insect productivity and biomass is lowest. So this shows us a little bit more about drivers of insects, insect populations, biomass, species richness, and that it's not one single driver like agriculture which drives everything, but it can be a combination. Species richness is driven by agriculture more than biomass, which is more linked to urbanization, for example. But I said I will also talk about climate, and I think that in this whole story we have been for a long time focusing on either land use or climate. And I think now more and more studies realize that these two things are connected. And this is one quite recent paper published in Nature just a few weeks ago, which did a similar space for time approach like the study I just showed you from Bavaria, but here global data was used. And here the main focus was on climate and interaction of climate and land use. And the most interesting result I picked out for you here today was that the effect of climate warming, which you can see here on the x-axis, the effect of climate warming depends on the background climatic conditions. So you can see here that species richness increased with climate warming in the temperate zone, while climate warming has negative effects in the tropics where temperatures are already high. So I think this is actually quite intuitive or quite easy to understand, that where temperatures are already high, an extra increase in temperature brings species more towards their terminal limits and so on, and therefore has much stronger effects compared to areas like we have it here in Central Europe, or maybe even further north, where temperature is in like a intermediate stage. A few degrees more is not that bad for many species. When we look at, or if we talk about temperature, then it's of course not only this large scale like tropics versus temperate and so on, but it can be also at a very detailed scale. And over the last years, what we became much more aware of is that the vegetation has a very strong buffering effect, and that the microclimatic conditions we observe in a closed forest under a closed canopy are very different to the microclimatic conditions very close by under an open canopy. So if you consider this, a closed forest like that has much more buffered temperature, higher humidity and so on, compared to an open site like this, even if this is at the same elevation and very close by. And this is something we are at the moment doing research on in quite some detail here in Berchtesgaden National Park. This elevational gradient which Christoph mentioned offers us a unique opportunity. We have, on a very small spatial scale, we have a strong gradient in temperature. So if we have like from 600 to 2000 meters, we have a quite strong change in temperature. Every like 1000 meters, we have a decrease of around 6 degrees Celsius. So we have this macroclimatic gradient on the one hand, and then within each of these elevational zones, we have a gradient in microclimate, which is represented by vegetation. And we can, at the moment, we can, do analysis, and we have done quite some fieldwork over the last year to tackle questions like how is macro and microclimate interacting, and how well can vegetation buffer effects of climate change. And what I think is very important in this whole thing is that we do not look at individual species only, but that we consider communities and ecosystems more comprehensively. Because, of course, many species are connected, are linked via trophic interactions, via other interactions. And therefore, if one species gets problems or is getting problems with climate change, another species which might have the thermal tolerances to get along with it could still disappear because its partner, its association, for example, plants and pollinators or plants and herbivores and so on, because its partner is disappearing. So what we're doing is we are sampling many different groups, plants, fungi, invertebrates, vertebrates, and so on, using quite a range of different sampling techniques to study how biotic interactions interact with climate change and how climate change is affecting not only single species but whole communities. As my last slide here, I want to show you a quite interesting figure which is based on a publication in Nature 2 years ago. And here the authors they draw the curve of historical biodiversity loss, and they projected how biodiversity might change globally depending on different scenarios. So if we do nothing, business as usual, then biodiversity is likely to decline much more, going down to like very low levels. If we increase our conservation efforts, we can maybe slow this decline and finally get to like a asymptote, which is which still is a decline in species compared to what we have now, but which is at least stopping this decline at some point. And what they ask is it possible to bend this curve of biodiversity decline? Are we actually able to get back to more biodiversity at some stage? For example, by not only increasing conservation efforts, but also by more sustainable production, more sustainable consumption, and so on. So this is focusing quite strongly on land use. And I think this is something that is really interesting to discuss, because it seems to be focusing quite strongly on conservation efforts, on land use. But I think what we actually have at the moment is really a game changer. If we consider climate change and how climate change could basically change everything, then I'm not so sure whether we are able to bend the curve by more conservation and changing land use only. And especially one thing is important here, and I think this is that if we want to mitigate climate change and slow climate change, then we also affect our land use pattern. We have, of course, more bioenergy, bioresources, and so on that we need to reduce climate change and to reduce our greenhouse gas emissions. But of course, if we want to produce more biotic resources, then this is another pressure that is actually increasing land use somehow, and that which might add or which might cause biodiversity loss by itself. So I want to raise the question whether it's possible to bend the curve of biodiversity decline, and how we can bring these things together, which are conservation, land use, which is of course strongly linked to how we consume and so on, and climate change and climate change mitigation. So I hope this is some basis for a discussion, and I'm looking forward to that. Thank you very much.